Welcome to the video lectures on fluid mechanics. In this video, we are going to study how to find out the head loss due to friction in pipe. Before going to that, we need to know what is a major loss and a minor loss. Right? Major loss occurs due to friction in pipe. Right? Due to friction in pipe. That means the loss of head due to friction in pipe is considered as a major loss, because in case of a long pipe, right, the long pipe here means the length is more than 1000 times of the diameter, that we call it as a major, that is called as a long pipe here. It is usually more than the loss of energy introduced due to other causes here. Other causes means those are the minor loss. Minor loss means it might be a loss of head due to sudden expansion, loss of head due to sudden contraction, that is entrance in pipe, loss of head due to exit in pipe, or loss of head due to sudden bend, long bend, short bend, or sudden gradual contraction, gradual expansion, and all those things. These comes under the minor losses. The major loss is only due to friction in pipe, loss of head due to friction in pipe. Right? This is given by Darcy's equation. This is given by the Darcy's equation. So in this video, we are going to derive the Darcy's equation for loss of head due to friction in pipe. Right? This what we have considered here is, we have considered a long pipe. Right? We have considered a long pipe. Long pipe here means the length is more than the 1000 times of the diameter. That is considered as long pipe here. So in this long pipe, we have considered two sections, that is section 1 and section 2. In section 1, the intensity of pressure, I will call it as P1. Similarly, in section 2, intensity of pressure, I will call it as P2. Section 1, pressure is acting in the direction of flow here in section 1, and in section 2 the pressure is acting in the direction opposite to the direction of flow. Right? Other variables here comes as the V1. Right? V1 is the velocity, V1 and V2 are the velocities at section 1 and section 2. Capital letter L is the length of a length between two sections, that is from here to here, and small letter d is the diameter of pipe here. Right? And one more parameter we will introduce, that is called as F dash. Right? F dash, I will write it here. F dash is nothing but the frictional resistance per unit weighted area per unit velocity, that is frictional resistance per unit area, unit weighted area per unit velocity. This is called as the frictional resistance per unit weighted area per unit velocity. This is nothing but F dash. And one more term we will introduce, that is HF. HF is nothing but the head loss due to friction. Right? That is head loss due to friction. Right. Now, similarly, we will be considering other parameters like P2, V2 are the pressures and velocities in the section 2 here. Now, I will apply the Bernoulli's theorem for this, that is Bernoulli's equation between section 1 and 2. Initially only I will divide this one. Applying Bernoulli's equation between 1 and 2. Right. Now applying Bernoulli's equation goes like this, that is P1 by rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2 plus I will write here as HF. Right. Now, why I am writing HF in section 2? Right. Now, let us assume the total energy. Total energy is P1 by rho g plus V1 square by 2g plus Z1 should remain constant throughout the pipe. Okay, that is P by rho g, V square by 2g and Z should remain constant throughout the section of pipe. Right. Here we are calling major loss, that is the loss of head due to friction in pipe. Due to friction in pipe, the total energy will not be same as that of the section 1. In section 2, the total energy will not be same as the section 1. Right. There will be some losses. That losses is occurred due to friction in pipe. So that is nothing but HF. HF is the head loss due to friction in pipe. Right. Now, in this case, what we are considered, the pipe is horizontal. In this case, the pipe is horizontal. So Z1 is equals to Z2. Right. That means Z1 minus Z2 will be 0 here. Right. And as the pipe, the discharge remains same, as in a pipe, the discharge remains same if the diameter does not vary. The condition here is the diameter is not varying. So in a pipe, the discharge remains constant. That is, Q is equals to A1 V1 is equals to A2 V2 for an incompressible fluid here. Right. As the discharge remains constant and area also remains constant, the velocity should also remains constant in section 1 and 2. So I can write V1 is equals to V2. So I can write V1 is equals to V2. Now I will substitute these two in the above equation. So I will get this Z1, Z2 becomes 0, V1 square becomes 0. So V2 square also becomes 0. Remaining will be only P1 by rho g is equals to P2 by rho g plus HF. Right. So I can write this one as HF is equals to P1 minus P2 by rho g here. Right. P1 minus P2 by rho g. Call this as equation number 1. Now we will be introducing one more term, that is F1. F1 here is nothing but the frictional resistance. This is nothing but frictional resistance. Right. What is frictional resistance? Frictional resistance, I can write F1 is equals to F dash, right, F dash into pi dl into V square. Right. F dash here is nothing but the frictional resistance per unit weighted area per unit velocity. Right. That is frictional resistance per unit weighted area per unit velocity. Right. Into pi dl, here is the wetted area. Right. Wetted area means the surface which is in contact with the fluid. Right. Here in this pipe, the surface which is in contact with the fluid here is the circumferential area. Right. Circumferential area is nothing but the wetted area here. Wetted area into velocity square. Right. This is the frictional resistance. Frictional resistance is F dash into wetted area into velocity square. So I can write this one as F1 is equals to F dash into pi dl into V square, or else I can write in one more term F dash into P into L into V square. Why I am writing P into L into V square here is, what is pi d? Pi d is the circumference of a circle here. That is the perimeter of a circle here. So perimeter into length here. Right. Pi d is nothing but the perimeter into length. Right. Now after this, what are the forces which is acting in this? Right. What are the forces which is acting on the fluid between section 1 and 2 here is forces acting between section 1 and 2. What are the forces we have here is, first force is the pressure force which is acting in the section 1. First one is the pressure force. First one here is the pressure force which is acting in the section 1. Second force is the pressure force which is acting in the section 2. Right? Here the pressure force is acting in the opposite to the direction of flow. And next one is the third one is the frictional force F1. Right. Third one is the frictional force F1. Frictional force is acting on the surface of the fluid element, that is which is in contact with the surface which is in contact with the fluid. Right. So, in combining all these forces it should be 0. Right. That is forces here we have this is the pressure force, that is P into A1. Similarly, P into A2 here. These are the pressure forces. So, I can write as P1 A1 minus, this force is acting in the opposite to the direction of flow, that is minus P2 A2 minus frictional force is also acting in the direction opposite to the direction of flow, minus F1 is equals to 0 here. So, I can write this one as P1 minus P2 into A is equals to F1 here. Right. Now, what is F1? F1 we have this one, that is F1 is equals to F dash PL divided by V square. Now, substituting F1 in the above equation, right. So, we have P1 minus P2 into area A is equals to F dash into P into L into V square here. So, I will write P1 minus P2 is equals to F dash into P by A into L into V square here. Right. Now, in the previous equation we have derived the head loss due to friction here. Head loss due to friction, HF is P1 minus P2 by rho g. Right. HF is P1 minus P2 by rho g here. Right. Now, I will substitute that value, that is P1 minus P2 will be rho g into HF. So, I will write P1 minus P2 is rho g into HF is equals to F dash into P by A into L into V square here. Right. Now, after this I need to find out head loss due to friction HF. So, HF will be F dash divided by rho g into P by A into L into V square here. Right. Now, what is perimeter P? Perimeter P is nothing but pi d. Right. Perimeter P is nothing but pi d here. F dash divided by rho g into pi d, or this d is a small letter d, pi d divided by area is the cross sectional area, that is pi d square by 4 into L into V square here. Right. Now, pi get cancels, d square and d get cancels, remaining will be HF is 4 F dash L V square divided by rho g into d. This is the head loss due to friction. Here F dash is the frictional resistance per unit wetted area per unit velocity here. Right. Friction resistance per unit wetted area per unit velocity here. Now, I will write HF, that is F dash divided by rho g is equals to F divided by 2g, where F is known as coefficient of friction. F is nothing but the coefficient of friction. Now, when I substitute this in the above equation, I will call this one as equation number 2. Right? I will substitute this in the above equation, that is HF is equals to 4 F dash divided by rho g is F divided by 2g, F divided by 2g here, right? F divided by 2g into L into V square divided by d, that is 4 FL V square divided by 2g d here. Call this as equation number 3. Call this as equation number 3 here. Right. Now, this equation is called as the Darcy-Weisbach equation. This equation is Darcy-Weisbach Wispach equation. Right. Sometimes what happens, they will not give the coefficient of friction. Instead of coefficient of friction, they will suggest the frictional factor, that is F star. F star is known as the frictional factor. Frictional factor. That means it is nothing but 4 times of F. Right? It is nothing but the 4 times of F. Instead of 4 times of F, substitute it as F star. That is HF is equals to F star L V square divided by 2GT. Right? Call this as equation number 4. Right? This all we can use either this formula or this formula depending upon the question what they are asking in the numerical here. That means if he has given the frictional factor, I need to use this one. If he has given the coefficient of friction, you are supposed to use this formula here. Right? So apart from this, the coefficient of friction F can be found out by 16 divided by Re. This is the condition for Reynolds number should be less than 2000. Reynolds number should be less than 2000. That means I can use Fe is equals to 16 divided by Re. That means it is a laminar flow. Sometimes the question will be in terms of turbulent flow. So you need to use this formula 0.079 divided by Re raised to 1 divided by 4. When I am supposed to use the Re should be in between 4000 to 10 raised to 6. 4000 into 10 raised to 6. Right? This is how we do the Darcy-Wispach equation. Right? Next we will be studying on the Chezy's formula. Right? Thank you.